In this video, we will be doing the Poisson regression, okay, which is also called the Poisson generalized linear model, Poisson GLM. Okay, so what this actually do? Okay, it is designed, this regression, okay, it is designed specifically to count to model a certain type of data okay, involving counts like events happening. Okay, for example, number of customers entering into a supermarket. Okay, so this is a common event, okay, and it comes under the this specification, the counting data. Okay, so this will be observed and explained by the Poisson regression. So some of the key features, okay, that can be explained over here. Okay, so the very first thing is that it models the count data. Okay, for example, some event happening. Okay, so the number of events happening over a certain period of time or space, so that is count data. Okay, so this Poisson regression, it models the count data. Okay, this count data is non-negative. Okay, so it can be either 0, okay, or greater than 0 up to infinity. Okay, but it cannot be negative, like an event happening. Okay, for example, number of students, okay, buying a uniform, for example. Okay, so these students, it can be either 0, 1, 2, 3 up to 100, for example, but it cannot be negative. Okay, so these numbers, the number of events, cannot be negative, the non-negative integers. Okay, and these non-negative integers, actually it represents the number of times an event is occurring in a fixed interval of time. Or space. Okay, so, or even volume. Okay, so for example, number of customers per hour, so this is the exact example of the above count data. Okay, or number of patients treated in an hour. Okay, so number of patients attended per hour in a hospital or in a clinic. So this is also the same, it represents the same kind of data that we explained above. Okay, so we know that in linear regressions, okay, in linear regression, what we assume two things. Okay, basically the normality, okay, that it follows the normal distribution, the mean of 0 and variance of sigma square. Okay, and constant variance, the variance constant. It is these two things are the basic assumptions of the linear regressions. But in the GLM, okay, or the Poisson generalized linear model, GLM, we assume that the response variable y, okay, it follows the Poisson distribution with a mean of mu, for example. Okay, so this is the basic assumption. Okay, secondly, the other thing is that the variance is directly proportional to the mean. Okay, so variance increases with the mean. Mu. Okay, so these are the two assumptions of the GLM. Okay, so these are the differences between the GLM and the basic linear regression. Okay, now in the Poisson GLM, okay, we have three main components. Okay, the very first components of GLM. Okay, so it has these are three basic components. Okay, so the first component is the random component. Okay, by random component we mean the response variable yi. Okay, it follows the Poisson distribution with a mean mu. Okay, so this is the very first component of the GLM, the random component or variable. Okay, the second thing is the systematic component, or we call it linear predictor. Okay, so we have a linear predictor. Okay, and it is equal to beta naught plus beta 1 x1 plus beta 2 x2. Okay, and so on. Okay, this is the, so the generalized form will be the intercept plus the slope for each factor into the factor value. Okay, this is the generalized form. Okay, the third one is the link function. Okay, so the link function, it is called link function because it links the mean mu I. Okay, the mu I is linked to the linear predictor. Okay, so it links these two things. So the basic link is that the log of the mu I, okay, it is equal to the linear predictor. This is the basic link that we use. Okay, so these are the three main components of the GLM. Okay, all the Poisson regression is based on these three things. Okay, these are the three components. Okay, now we come to the key formulas and equations, okay, that we use in the Poisson regression.